Alright, welcome back to Ubad's lab, and today we're going to be going over how to draw Lewis dot structures. I think this is obviously one of the most basic parts of chemistry and is definitely something very important to get down well. Let's get right into it. So today I've been working on making a model rocket for next week's video, so definitely stay tuned for that. Working on the rocket fuel, it's most likely going to be sugar based. Let me just get the chat pulled up in case anyone has any sorts of questions in the chat. I'm open to answer questions during the video, so feel free to drop questions. Alright, what's up? What's up? So I want to show you guys this. This is the body of the model rocket that I finished putting together today with my brother. Nice cap for the deployable parachute. And we got 4 wooden fins. And this is a 16-inch PVC pipe. And we're going to have a little engine in here that will burn the fuel. And hopefully this will launch nicely next week, and it'll be a really cool video, so stay tuned for that. Alright, let's get into the actual video now. So today we're going to be drawing Lewis dot structures and be working and explaining my way through them. So we're going to start off with CH2Br2. CH2Br2. So what you want to look at when you start is which of these elements wants to create the most bonds out of all of the elements. And the answer to that question is carbon, since it has the least amount of valence electrons while still being one of the elements that is looking to take in electrons rather than give away electrons. So, for example, if it was an element with, this has 4 valence electrons. If it was an element with 3 valence electrons, then it would rather give up those 3 rather than take in more. So carbon is what we put in the middle, since it wants to create the most bonds. It wants to create 4 bonds, since it has following the octet rule. It has 4 valence electrons. It wants to create 4 bonds to get its octet of 4 valence electrons. So we have carbon with 1, 2, 3, 4 valence electrons. We have hydrogen over here with 1 valence electron, and another hydrogen over here with another valence electron. We have 2 BRs. We have BR. BR has 7 valence electrons. It is a halogen. 7. BR, 1, 2, 3, 4, 5, 6, 7. And now if we have a look at this, we can see these electrons over here can bond. These electrons can bond, these can bond, and these can bond. So we have 4 bonds over here. So if we can redraw this, we get C in the middle with a bond to hydrogen, a bond to hydrogen, a bond to Br, and a bond to Br. And then after this bond, it has 3 lone pairs left over. So this would be the final Lewis dot structure for CH2Br2. Alright, got that one down. Seeing anything in the chat? Nope. Alright, feel free to ask any questions as I'm going. If I don't make anything clear, just let me know. The next one that we're going to be doing is HCN. So let me erase this real quick. And today's going to be a relatively short video. I just have this 2 more examples now. So it's gonna go by pretty quick. All right, we got HCN. All right, so again, with the ask yourself which one is going to want to bond with the most, and it's really a question between carbon and nitrogen. Carbon has 4 valence electrons, nitrogen has 5, so carbon is going to want to create more bonds than nitrogen. Nitrogen is going to want to create, three bonds, since it has 5 valence electrons, so 3 bonds, and carbon has 4, so it's going to want to create 4 bonds. So let's start with carbon in the middle, right? And it has 4 valence electrons. Hydrogen over here with 1, nitrogen over here with 1, 2, 3, 4, and 5. Okay, and now let's start planning out our bonds. Carbon likes to make 4 bonds, so let's keep that in mind while we're doing this. So we got 1 bond over here, we got 1 bond over here. Now, this lone pair can also bond over here. So we know that nitrogen likes to make 3 bonds, and it's only made 1 so far. And carbon likes to make 4 bonds, and it's only made 2 so far. So we can fix that by making 2 more bonds between C and N. So 1 bond here, and 1 bond here. So this becomes C with 1 bond to hydrogen and 3 bonds to nitrogen. And then it has 1 lone pair left over, which is this one. It's kind of hidden over there. This electron and that electron. And that's the final Lewis dot structure for HCN. All right. Let's get into our next example. I wanted to do a polyatomic ion for this one to show how you work through ions. Ions are anything with a changed number of electrons, so plus or minus. So it's given or taken away electron. Okay, we're gonna do NH4 plus for this example, and this is the last example for today. NH4 plus. Okay, we know that obviously nitrogen is going to want to bond the most. It's going to want to create the most bonds. It's a better way to say it. We got N over here in the middle with 1, 2, 3, 4, 5 valence electrons. And then we have hydrogen, which is 1. We have 4 hydrogens, so 1, 1. Okay, we got 4, and each of them have 1 valence electron. And then this plus means that there's 1 electron lost, so we can X this electron out. And then we can start creating our bonds, which would be here, 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 and here. So we know usually nitrogen likes to make 3 bonds, but in this case it makes 4 because of this lost electron. And let's rewrite this over here. We get N, 1 bond to hydrogen, another bond to hydrogen, and over there. And then since it's ion, we have to do the whole thing in brackets and put a plus over here. And that's the final Lewis dot structure for NH4 plus. And yeah, I hope this video helped. I mean, it's a pretty simple topic, but it's always nice to look through, and I thought it'd be nice to explain today. So, thanks for watching, guys. Don't forget to subscribe if you enjoyed the video, and stay tuned for next week when I launch this rocket. It's gonna be definitely a really cool video, and yeah, I'll see you guys next time.